Alright guys, I'm super excited to go through this today with you, and this is a video I've wanted to make for a long time, actually months and months, and it's going to be a very in-depth video. In my opinion, it may be the best sort of crypto video you ever watch if you're learning and want to understand more about the blockchain, because I'm going to go in and really give you a detailed overview and try and simplify and break that down and show you what's making our system tick. So, and this is like for any dApp, and it's going to really show you how the chain works. So this is like an undercovers view of exactly what's happening when you're interacting with dApps and understanding more about the blockchain, the code on the chain, the functions, and things like that. So stick with me. I hope you want to stick around and learn more, because it's super fascinating, and the thing that keeps me excited about the industry is the technology behind it. Definitely is very good when it comes to blockchain and everything that we're doing in the background for all of the benefits that it adds with transparency and things like that. But I really want to show you through what's making this dApp tick. So what we're doing here, we're on the front end, and this is what you interact with. And all we're really doing, for simplified terms, is we're making it simple for you to operate. That's all we're doing, right? There's a lot of code behind this. There's a lot of scripts. There's what we call an API in the background, which is pulling down data, so it's all sitting there. So it's not doing like hundreds of RPC calls to the chain, is what we call it, where it's actually then going back to the chain. It's doing it, having the data sitting there prepared, ready to go, so that as things change on the chain, we're updating it, not having to poll everything every time, because it's just not efficient to do it that way. But let's go in and have a look at the contracts, because you've probably heard about a smart contract by now. The smart contract is what's powering and holding the rules for a better word, right? The rules of what the contracts state are allowable. So we've got lots and lots of contracts, as you know, on lots of different deployments. They're all sitting there, and the best thing about them, these smart contracts, is once they're deployed, they just do their job, right? So they continue to post to the chain, and also you can read data from the chain. So I'm going to go through and I'm going to show you, and you could come and click on these. You could take this, copy it, and then post it into the scanner. For this instance, these are our contracts on FDM. We're going to post that address in here, or we're going to search that address. It's then going to bring up this contract, and it's going to show you some pretty cool information, right? So now you're digging into the background, the back end, and starting to understand what makes our system tick. This one here in particular is the equal contract itself. So it's the one that the tokens were created out of. It's got obviously the token ticker here, and then if you come along here, you can see people have probably sent tokens to this address, so they're sitting there. I'll show you some other contracts later on, so you can sort of even have a look at your own address and where you can sort of tick through here and understand more in this little drop down section. But you're seeing all the transactions that have occurred. So on this contract in particular itself, there's been almost 24,000 transactions. They're approval transactions, right? And I'm going to show you how to do an approval in a minute and walk you through that. Now, an approval is done to allow tokens to be spent for generally for a swap or a transfer or something like that, or for a swap, right? Because you need to approve that contract to allow that swap to occur. It's just a safety function that's built in, right? So I want to click on here, because another cool thing that you can do is you can start to go in and get more data. So don't be afraid to click around in the scanner, right? You're not going to hurt anything by clicking around, especially if your wallet's not connected, all right? So you come in here, you can see the holders, you can see the contracts, right? These are other contracts sitting there that are holding equal, for instance. So this one here is the VE equal contract, and we'll go into that further in depth and give you a good understanding of how that one's working in a minute. But if we come down here, you can see these are holder addresses. So the ones with a contract next to them are contract addresses, and the other ones are holder addresses, okay? So you can come through, then you can click on these, you can go in there, you can further look, you can look at this guy's address. Let's do it, all right? So we'll go in there quickly, have no idea what this address is. We're just gonna bring it up. We actually wanna get directly into that address. And then we can go in and, like I was saying, we can have a look at every token that's sitting in that address. So we can come through and roll through here. We can see if he's got an LP. We can see if he's got NFTs. We can really scan through and see what this address has. It's all public information, nothing to be hidden there, okay? So what we do is you're just going to roll back to the equal contract itself, and as you go along these tabs, you're going to find something, a tab called the contract tab. Now this is where all the magic happens, okay? So what's happening is a contract is being deployed to FTM, and that contract being deployed then comes on here and basically acts with functions that allow it to do what it's told, or those rules that are being set, like we spoke about before. So I want to come in and I want to show you the first thing you can go on is the code tab, and you can understand the code behind the contract. So what that means is you're able to come through and have a look at the functions. This is a constructor call here. That's something that's called when the contract is created. Then you've got your function here that's telling it to do something, and so on. So you're going to keep coming down. Now, I'm not a dev myself, but I've spent a lot of time reading through code, and you start to really get to understand it. It's actually, to a degree, like once you understand sort of how it's operating in the background, it's laid out pretty well, and the functions are describing, it's a public function. Something to look for if it's a public function and it's calling your tokens, well then that's a red flag, right? So these are the things that you can start to look for. A public function to view something is not a problem, obviously, and then obviously the only owner type function where it's only allowing you to withdraw the tokens and things like that is super important with contracts, right? So all of our contracts are battle-tested contracts. They've been forked from audited contracts, and then on top of that, there's immutable contracts which house your funds, and we're going to go through that in a minute. So really important section there too. Just trying to give you like as much detail, really just sort of show you everything, and then let you understand and try and make your decisions on how it works. So I'm going to show you this contract in a way that shows you that this is what we call a proxy or upgradable contract. It effectively means that it can be updated, right? So unless you really trust the developer, you don't want an upgradable contract sitting on your funds, where your funds sit, because then it can be upgraded and your funds removed, okay? This contract is the equal contract, so it's an upgradable contract, but it doesn't house funds, okay? And there's ways to protect yourself a little bit there with like time lock, so that you've got time that a time lock contract could sit over a contract like this, so that there can't be any interactions made on this contract for a certain period of time, or a multi-sig where multiple people need to sign off, like these contracts have a multi-sig there to allow for multiple signatures. So that there's lots and lots of things that sort of safeguard a proxy contract as such. But the main thing, and I'm going to get to it in a moment, is our pair contract and the gauges and things like that. They're all immutable, so there's no changes that can be made, and that's very important when you're trying to understand more and more about the chain and get yourself to that level of understanding where the risk lies. Right? We've got lots and lots of funds in our contracts, so obviously the people that understand the chain know that those contracts are battle tested and there's no access to those funds, and they're feeling safe about those. Okay, so and I'm just being transparent and showing you through all of this. This is stuff for you to really take to the next level and understand. So let's go to the read side of the contract, because this is an important part of the contract that allows you to read the functions that have been written here. So all of these functions written now have the ability for you to call them, right? You don't need to hook your wallet up, but you can call these functions and get the data back. And I'm just going to quickly go in here and grab an address. I'm going to put it in, and I'm going to show you. This is a manual interaction with the contract, and you're in FTM Scan and you're pulling back the details on the balance of that address. So it's just asking the contract how many tokens are sitting there in this wallet that we're querying. Could be any wallet that you query. Could come back that there's no tokens if there's no tokens. So one thing that looks like there's a lot of equal in that. That's not correct, because there's a lot of math behind this, right? This is an 18 decimal token, so you need to remove 18 decimal points to get the actual amount. Now, I want to go in and show you. So we know that 637.92, and I know that. I can see that I'm not just looking at the 18 decimals and taking off. I know that that's what's in the wallet. But you can see that there is basically what we're displaying. So we're not pulling it directly from the contract for that call there. It's coming from an API which is completely updated as things come on. But we will call certain aspects and then store them there. And as things change on chain update and call certain specific things, and I could be wrong, we might actually call this directly from the chain for this one because it's something that's so quick that needs to be updated. But there's rules behind that developers go through and go, well, can we have this one stored? Can we not have this one? How do we speed things? How do we increase the user experience? But what you're coming in and seeing this DApp is the data pulled up. You're going, oh, okay, I can come in here, I can swap this equal. And it's basically running scripts that then come in and allow you to swap that. If you pop it in, it becomes the input and then allows you to swap. So if we go back to the contract, you can see that 637 is the same, but we're going to go to the right side. Like there's lots of different functions in this read side that you can go in and understand. The minter, it shows you the address of the minter. You click on this, it's going to take you to that contract. We've got a minter contract. We've got, lots of things that are interconnected and interoperable across these contracts. But let's go into the right side of the contract. What you need to do is you need to connect your wallet. So you come here, you add a wallet, you connect it to here. It needs to be on the FTM network for using FTM scan. And then effectively you're going to connect and you could come in and approve. So whenever you do a transaction in a swap, you've probably noticed you do an approval. So it comes in here, adds the address that needs approving, and then the value that you want to approve up to, and then you write to the contract. This contract now has approved that address to make that certain transaction. You might want to come through and do a transfer. You can come in here, add an address and a value, and transfer it directly from the contract. The transfer from function goes into the same way and goes in and does some transfer from, and you can transfer from to other contracts to allow it to notify it. There's lots and lots and lots of, like you can see that the set minter address, so the minter address could be set, but that function will have only certain addresses that are allowed to set that function. So I'm just trying to go through and really get transfer ownership of the contract. So you could transfer ownership of this contract. So there's lots of functions that are built in, and these functions go out throughout the whole of crypto and are built in and allowing people to operate. So what you're seeing here, this approval, is exactly what happens when you come in to do a swap and it goes and does an approval. It just inputs the data for you. It basically just goes, here we go, and write. And the way it does it is by using the ABI. So it's utilizing the ABI to then come through and talk to this contract within the front end using a language, what we call, in most cases, React or something like that, is using that API to call a script to get the data and then do the applicable requests that are granted there. So effectively, I've given you a pretty good understanding of just the equal contract, and that's a simple contract, right? So you've probably had a meme token or whatever. Meme tokens in a lot of cases might have less functions than this or a couple more functions, but they're almost like a static token, right? That's what those meme type tokens are, right? They don't have a lot of substance behind them or operating system. When you come to something like us, you're effectively getting a huge list of interoperable contracts that are doing all of the functions like the NFTs and things like that in the background. So this contract here, I wanted to quickly go through and show you. This is our VE equal contract, right? So the reason I want to show you this one is it's super cool. Lots and lots of things that can be done. You can get the balance of an NFT. Look, let's just type in any. Let's say that there's NFT 125. It's got a balance of 0, so that mightn't exist or been burnt. But let's just try NFT 650. It's got a balance of this, remembering that it's got all those decimals. So if we want to interact at this point, we've got to remove them. But when you go across to our DApp, we're doing all of that for you, right? We've got the math sitting in the front end and removing those digits to display the right amount for you, okay? So you're starting to see how you can, do certain attributes within these contracts, right? This is the read side. This is no wallet require connection. You can always come in here. You can't break anything. You can add the addresses. You can just basically come through here and play around if you want. To get the correct inputs, you need to know what to get the output, you need to know the correct inputs, sorry. So that's something important that you'll need to know. And also to get a transaction to happen, you'll need to know exactly what's required. So you could come in, so whenever we create a lock in our system, and I'll just go back, and we go to the lock function, and we create lock, there's our function. We're going to put the 637 in. That's what we want to lock today, the 26-week lock, and we lock, right? So let's go back to this contract and have a look. We're putting in that amount, so we've got to put that in, remembering the 18 decimals, so we're going to have all those zeros or whatever that we want to lock, and that's going to be our value. And then we're going to do the lock duration, so we're going to do that for, say, 26 weeks, which is going to be another number. You're not going to be able to just put 26, you're going to have the Unix timestamp for that period to make that lock, okay? But we're doing all of that and we're simplifying that in the front end, right? That's what these dApps, and it's a huge code base. Like, I don't think we always get the credit for how much software is sitting here allowing this to all happen in the background so that you don't have to interact with this. But I think it's super important to understand that this is what's happening in the background. And I can guarantee you, if you come in here and try and do that, you'll fail straight away in trying to make that transaction, because what's going to happen is you're going to have to have made an approval in this contract first with the contract address. So you're going to have had to have come across here, taken that contract address, added it into our spender address, and then we're going to have to put a value to open up so to say that we can do it before it's going to allow you to interact. But the front end is running through a script and it's doing all of that for you, okay? So that's exactly what the front end is, all the value it's bringing to you, and that user experience, so you're not having to go in here and have a look. Now I want to show you, this here contract has the 2.256 million equal in it. So that's how many equal are put into this ERC 721 wrapped contract, which is our VE equal contract. But you'll see that our voting power is only 1.819. So what that means is that's all the decaying NFTs in the background, right? So that's the total vote power at the moment. But because everyone's not locked for the 26 weeks, we know that they're close to it. Some might be 24 weeks. We're a little bit throughout the week, so NFTs have been decaying. But there's 1.8 of vote power. But as I showed you before, there's locked in this contract 2.256 million equal, okay? So that's giving you a good understanding on how this contract works, right? It's a pretty cool contract, very integral to our system. It's the one that controls all the NFTs, okay? And then we move along to this one here, and this is a very super important contract. It's our voter contract. So the voter contract links into almost everything in our system, and you can see the amount of functions we've got, right? And I actually brought this along, and I opened this one quickly so that I remembered. Like, if you want to reset your vote for the token ID, it needs to come in here. This is where you're resetting that, but effectively that's all being done on the front end for you. It's coming and calling this function, right? If we wanted to notify a reward amount, we'd come in here and use this function, right? If we wanted, let's create a gauge. We wanted to create a gauge. What we'd have to do is get the pool address. So let's use equal, for instance. We get the equal address, the pair address, which is sitting here in Dex Screener, or even in our dApp. You can come along and see this sort of stuff. So we want to go and find the equal address. We go to there, and you can see our address comes up here. Just how our system's labeled, but there's plenty of places to come and grab that address, all right? So you come in, and now you've got that address. You can input it here, right? And as long as it's whitelisted, and that's another function that we've got, that we've had to whitelist it first, then you can then create that gauge. So anyone can come in. It's It's a public function that any address can come in and do it, providing the whitelist was given by the owner of the contract in the first place. Okay, so that's how all the things are talking together, all the rules, all the principles, the agreements that are being made within this contract. Okay, so you could come in and manually claim your bribes, but you've got to put it in the right format. You've got to have the addresses of the tokens in here, the bribe address, so you need the bribe contract address and things like that. I'm going to show you here because this is something that we use a lot, especially in the back end, because we might have this equal contract, so we get that pair address, but we might want to know the gauge, because we need to know the gauge of it so that we can then call distribute if maybe it didn't distribute, because there's other functions that call that are written in there to do automated procedures. But hey, first time whenever a new contract is set, we call that gauge and get it running. But anyone can call it. We just do it obviously as we manage it. Let's query. So what do? We end up with the gauge address. So now we've got the pair address, and the gauge is where the tokens are sitting in. So let's click on it because it'll open it up. And you can see that this is the address of basically where the VE equal is the equal FTM is sitting. Okay, and within that we have another contract. And this is the point I wanted to make to you, where this is what we call an immutable contract. See how we don't have those extra two tabs? We've only got the read and write. So when you come in here, there is no upgrading this. These functions are these functions. The only things this contract will ever be able to do is utilize these functions. There's no adding functions, anything like that. Effectively, everything here has been set. This is a battle tested contract. It's the gauge contract that sits in on all these other solidly type models, and effectively other type gauge contracts would be very similar in their aspects. So you're starting to see that one. Then we're going into our pair contract, all right? And our pair contract, as you can see, has the equal FTM sitting there. It's sitting there in its values as we see it here in its pool values of how much equal sitting in there with FTM. So you're starting to see, but hey, guess what? Dex Screener's pulling that data. It's taking it from here, it's taking it from the pair contract, and then it's pulling that data and displaying it for you, okay? So I don't want to go too much further onto that because I think I've given you a pretty good understanding of the background. I'm going to simplify things for you. I want to show you a simple way now to take that pair contract, because now you know how to find a pair contract. That's the liquidity pair contract. And then I'm going to take it to DBank and I'm going to add it in, because you can put someone's address in here or you can put a contract in. So now you can see it like in real time, right? You're starting to see the tokens sitting there in the contract. That's the exact amount sitting in that contract. And then you can go and have a look at the transactions, and much easier to read transactions when you're in DBank because that's displaying it for you, right? So it's showing you what's occurring. See this receive? This is a contract call here that's occurring with Tarot, because obviously people are putting their tokens or their LP into Tarot. Okay, so there's a good example of other contracts interacting, and we've got this layered system of other contracts calling functions from our contract for this instance. So that's the pair contract. I'll show you the gauge because it's another cool contract that's going to give you a bit more of an understanding on the equal FTM contract. So we go in there, it's going to have the same. So now you can see it showing it as the liquidity pool. DBank do a great job of going in there and having all this data so it displays well. This is exactly how it displays when you put your address in, and it shows you all the things that are labeled under your wallet address, and for all the different protocols. But what you're seeing here is the equal. So now you're getting to see the gauge contract. What happens is after you make those votes and you guys decide where the equal goes, that equal then gets sent directly to this gauge contract, and then there's a distributor sitting in there, there's a function which distributes that to the people that place based on the amount of share of that gauge, that pool that they've added to that gauge. It distributes those equal to people. So that equal sitting there is sitting in the contract ready to be distributed. So it's a really, really good way when you come into Debank to get a much simpler view rather than coming through these, doing it all on the scanner where it's just a little bit more difficult. And the better you get at it, the more time you spend on the scanner, because it is pretty easy and you can get through the lines quicker and stuff like that. But I'm going to go in here and I'm going to show you, look, these are basically the contract interactions. This looks like it's someone calling the equal, right? For it could even be tarot. So you can see how often this contract's getting called for the equal, right? Because it wants to get those rewards and it's doing whatever the functions are on that. You will see that people that are in there are effectively, because this is calling equal actually for I would say a lot of potentially all of the contracts from the tarot caller, but effectively in a lot of cases when it's not as busy as this one, you'll see like which wallet, how much they called, and then you can track things like that. So I think it's super cool to come in here and really get in touch with what's powering what you just see as a front end system, right? Then we go and we swap chains and we do all of that. So there's so much more behind this. There's so many different functions. Like if you go through here and have a look at all these pages, right? And what we're doing, we're pulling down data from these read functions, or this read side of the contract. We're calling certain functions and then we're pulling data back, all right? So that's what we're doing when we bring that data up for you. And then when you put an input, it's coming through and it's doing it in the right side of the contract, right? It's basically filling that in for you based on whatever inputs are put on the front end, and then you've just got to click your wallet because you're connected to our ABI, you're connected to our contract, that we've got the wallet connect in there, you're utilizing your Ravi or your MetaMask or whatever it is. So I think that's a pretty detailed view. As I said, this is something I've wanted to do for a long time. It might not be the video that everyone is interested in, but definitely if you're passionate about blockchain, I think this gives you a huge overview of exactly the power of the blockchain.